Hello children, today we are going to solve page number 28, question number 10 of geometry of 9th standard. A diagram is given to you and information is provided. We have to prove two parts in this question number 10, that is on page number 28. So let's begin drawing a diagram. First we will draw a triangle. We will extend one of its lines so as to make exterior angle of that. Now we will name it as triangle DEF with extended part up to point M. Now here the angle is bisected by a ray, so we will make two equal parts of that angle. Here also we have got a DFM bisected by a ray meeting at point G. So these two angles here over here also are equal, that is angle DFG and angle GFM, both are equal, so we'll mark them with equal marks, equal symbols. Now here in this figure DE is parallel to GF, a very important information provided to you. Now next thing is you have to prove two parts. First part is to prove that angle DEG is half of angle EDF, and second part is to prove EF equals to FG. So we have got two parts to prove, so let's begin. We will apply two known properties, exterior angle property and one more property of isosceles triangle later on. So these two angles we will make them as XXY because they are equal. So XX will make 2x. Total of that is 2x. But here if you see, this is parallel line. And in parallel line we know very well that corresponding angles are formed by transversals. So let us examine here these two parallel lines, and they are making F-shaped angles as corresponding angles. So just see the figure again, which two angles are corresponding there, DEF and GFM. If you see DEF this angle and GFM this angle, these two are corresponding angles made by those two parallel lines. So if this is 2x, we will write 2x here, but these two angles are equal, so we will write 2x over there as well. Total it will make, total of this will become 4x. This is very important, you have to note it down. Total of this will become 4x. And now as you see in the figure, we will make use of exterior angle property. This is a whole exterior angle. That 4x part is an exterior angle. So we write here, now we go to prove things by exterior angle property in triangle DEF by exterior angle property. So here it is, by exterior angle property. So exterior angle property we all know, we are all aware of that. Now it's time to apply it here. Angle DEF, angle DFM, if you see DFM is the exterior part, so we write angle DFM equals to, leaving the next angle we go for another two exterior angles. Okay, these two exterior angles, so two interior angles, remote interior angles. So here we write angle DFM equals to angle DEF and angle EDF. We are applying exterior angle property. DFM equals to DEF plus EDF. Now as you see in the figure, this whole is 4x, so I have written there 4x. We are writing 4x there in place of that angle. Now DEF, you see here excuse me, that is x and x, so 2x I have written, and that angle we don't know, so we will write a question mark there, and then that name will remain as it is. Now 2x you bring this side because they are like terms, you subtract it, and their EDF will remain as it is. So 4x minus 2x will give you 2x, and so here we got the value of EDF value we have got. So we have got one of the remote interior angle as 2x again. Now if you compare 2x and 2x, these two angles are same. See, this is also 2x, that is also 2x. So angle DEF and DF becomes same. So from the figure, if you see the figure, you get two angles equal. These two angles equal as 2x and 2x. So let's write it down here. We will write down here as angle EDF equals to, keep seeing the figure, EDF equals to DEF, which we have proved by exterior angle property. These two angles are equal and both have the same value 2x. We say like that. That means for our consideration we are taking it for convenience. So proof become easy. Okay. So here we have got two angles equal. Now again you keep seeing figure again and again, because from figure we will derive all these things. Here we have got a DEG and EDF. So we have out of this, here we write this DEF into two parts. We will split it into two parts. EDF we write as it is. Now you see DEF there. DEF is made up of two parts. Both the parts are x and x. So one angle we rewrite as DEG instead of DEF, because DEF, as I showed you, we do not want it in our proof. So we have to replace it. So we write DEG plus, if you see the figure again, so this plus this plus this. So we write another angle GEF. So we have, but GEF we don't want. So we will replace it with its equal angle. We want only DEG and EDF. So EDF already we have. DEG we need it. So we write DEG as it is. Well, and this we will replace. This is equal to DEG. So again we will write DEG in place. Both are x and x. So we will replace. We need not write this. We will replace equal value. So equal value is x again. So same angle. DEG you write down once again in place of this, because they are equal and we will show it separately. Yeah, so we show it why we have replaced. You might think where GEF has gone. So GEF is not gone anywhere. Its equal value has been substituted in its place because we need that. And both are x because they are equal. So both are having x value. So both are equal. Now this EDF will remain as it is. Here if you add, these are two same, so you add 2 times. You get 2 times DEG. Now 2 you bring this side, this is multiplied here, so it comes here and it gets divided there. That is becomes twice, it becomes half here. So half of EDF equals to DEG, angle DEG. And that is what we were supposed to prove. Our proof is done. So we just write that is, we will write in a proper order. We write in a proper order there, which is required order. So DEG becomes half of angle EDF, and that's your proof. Part 1 we have completed. We have completed the part 1 proof. Now second part, you have to prove two lines equal, and that can be done by using isosceles triangle. So I leave it for you to do yourself. I'll just give you the hint. These are two sides that you have to prove. So just look at the figure very closely. Excuse me. So here you got a triangle, this EGF triangle, EGF. In triangle EGF you have to show two lines. Here if you notice, you are getting lines. The lines are parallel. This line is parallel to this line. Now this time we are getting a Z angle, Z shape. This Z shape means alternate angle. So one part, this is X. So obviously one part is X. The other part, that is also going to be X. So this is X. So this also is X. Now if you notice this triangle, you got a 2X. In angles you got a X and X. Here X and X. The opposite sides of equal angles is always equal. That's the property of isosceles triangle. And once you show this is an isosceles triangle, you can easily say that therefore the two sides are equal. This is, I have given you hint. Taking the help of the hint, you try your own self. Write comments in the comment box and let me know how did you like the video. Bye bye. We'll see